Wonderful. Good evening, everyone, and glad to connect with you all again. Hope you're practicing well. And let's begin. So why we are connecting today? What exactly is the agenda of this particular session? And what we are basically going to learn in today's session. Right? These are the primary things that you need to understand. As you have already seen the title of this particular session, we're talking about deployment. Right? So if you look into any of the data science projects, any of the production big giant organizations, when they are trying to implement solution, developing a model is not a big challenge. It will hardly take 2 weeks, 3 weeks. But majority of the time and the effort that is invested goes in the deployment fund. And there are various ways. And as and how machine learning subject itself, data science subject itself is evolving, the latest of the technologies are getting embedded into this the entire paradigm of technology or the data science life cycle. But to put things very simply to you, when you are dealing with any project, we go through this life cycle. This is called as crisp DM life cycle, right? Please stop your videos. We don't want webcams to be on, please. Right. So we have DM life cycle here, wherein we start with business understanding. We collect the data, we understand the data, we do pre-processing, EDA, and feature engineering. And once these steps are done, of course, majority of the time before you deploy the solution, while you're developing the solution, majority of the effort goes here. Probably 60 to 80% of the effort goes in preparing your data. And post that, we use machine learning algorithms to develop your solution. Data mining, supervised, unsupervised techniques we are talking about. The statistical or black box models that we develop, we train our models and we use that trained model for prediction. So we develop the model. Probably it will take a little time to develop because we have to do multiple models. And then we will evaluate the model and decide on what is the best model to implement. Now, this is all fine. Now, once you are developing the model, right, majority of you people already know this equation. This is called as the base equation, right? Just refreshing your memories. This is a base equation which is used for doing the predictive analytics. Y is a function of X. And our machine learning algorithms are designed or trained in order to identify what is this mathematical function. What is the representation of the relation between Y and X. Now, once you are identifying what is the best equation here in these two steps, you have to use this for actually predicting on new cases. That means you have to give this particular solution to your client. Now, how would you give this solution to your client? We are not developers. Remember, we are not coders. We don't have any development or operational skills. We are data scientists. We understand data better. We understand business scenarios better. We can map those two. We can do statistical computing. We develop machine learning algorithms. We try to predict the outcome upfront. We can try and explain those conditions. But how do we actually give the solution to the client so that they can actually use it? We are learning R code or Python code. So we are going to use these very easy high-level programming languages to develop our machine learning algorithms. Very good. Do you give the code directly to your customers? Not really. Don't do that. Because your clients may not have the capability. They do not have the technical staff who can actually take care of this algorithm and execute the code and do the predictions. That's not possible. Now, how about giving an application? This is no-go. Of course, if your client says, hey, give me the code, I have my own team who is going to make sure that the solution is being implemented. They have their own front-end team, integration team, operations team. They can do it, no problem. In such cases, you're going to give them the code, no problem. But what if your end customer says, I want to finalize a final product. I don't want code. Don't give me a code. I don't understand anything. So in such cases, you want to give an end application. Now, when I say application, very simply put, you're going to give a mobile app or a HTML web pages, wherein you'll have a graphical user interface. You're going to give the input. This is called as input, right? So you submit the input and click on a button which says predict, and you'll get an output. Now, how about giving this kind of a user interface, an end application to your client? Wouldn't that be more useful to the client? Right? So that's what we are trying to learn today. Now, again, you're saying that, hey, I have to learn something new because you're talking about HTML applications, web applications, and all that. Of course, we are going to develop HTML or web pages. We'll not do mobile applications, that is out of scope. That's a completely different platform, right? We'll not get there. ML operations or whatever the machine learning algorithms that we are developing, the technology is not evolved yet to that place where you can directly build a mobile application on top of that. But web applications, very easy, we can do that. So we're going to learn that. Now, the prerequisites for this, if you are using R to develop an end solution, is nothing but R programming. If you know this, very good, no problem at all. Blindly, you can start developing an application. But if you're using Python, then probably having some basic knowledge about HTML and CSS, cascading style sheets, right? That's HTML markup language and cascading style sheet language is something beneficial. It's not mandatory though. And these are not difficult. If you probably spend 5 to 10 hours, you'll be able to understand what these things are capable of. You don't have to become a perfectionist, or you don't have to learn the skill of doing a language or developing HTML code, but understanding what does HTML language is all about, what does CSS is all about, would definitely help when you are using Python. These are the prerequisites, guys. Now, we understand the importance of deploying a solution. Even today, as we are speaking now, if you ask any of the AI-based organization, you go to any MNC or any startup, the majority of the time they spend is on deployment. Okay, and this is something which is now becoming very, very, very vocal in the space of machine learning and data science community. The term is called as MLOps. Okay, we are launching this MLOps, machine learning operations modules, the separate different training dedicated for data scientists who are capable of developing these solutions. They'll also have to learn how do they deploy a solution in production environment. This is basically two parts, machine learning and operations. Okay. Now you basically say that, hey, I developed the code. What you are doing these life cycles, right? You understand the business requirement. You're basically collecting the data and pre-processing the data. Then you're training your models and you're evaluating the models. Very good. Now you're saying that, hey, developers, take this code and make sure it is deployed to the client. Now these people would not understand what does this means actually, what exactly it is. It's not Java that we are doing, right? Something new. So these people will be lost, because the challenge with machine learning algorithms is it is a cyclic process. It's constantly needs to be evolved, constantly needs to be trained. New data would come in, so new ways of pre-processing is required, right? Consuming that raw data will be a big challenge. So constantly you have to make sure the model is also evolving. So developers would struggle in doing this. So as I said, there are different techniques. You have different various techniques that we can do. And thanks to the cloud platforms, whether you talk about AWS, whether you talk about Azure, or you talk about Google, GCP. Or let me write as GCP in short. Yeah. So these are the most, or I should say, top 3 cloud platform providers, which are in the top 3 positions, 1, 2, 3. Now, these cloud platforms have data pipelining and deployment automated solutions. That's exactly what is your deployment on cloud. That's what would be covered in ML operations. Now, on-premise, when I'm trying to do this, it's better to do a web application to start with. Now, let's jump into something called as R Shiny. We'll talk about this first. So let's assume that you are familiar with R programming and you're developing a machine learning algorithm. Let's talk about a simple machine learning algorithm, linear regression. Majority of the people understand what is this. It's a simple mathematical equation. Y is equals to ax1 plus bx2 plus c. Assume this is your equation. Some mathematical equation I'm drawing. Okay. To be more generic, I'm using this equation. I have output variable which is getting affected by 2 input variables. Assume. So we have mathematically expressing this relationship between x1, x2 and y. So you're going to give this R code to your client. Okay, this is developed in R programming. No, you would not really enjoy. Now, what you can do is generate a web application where you say input 1, you give input 2. You might want to write some description and all that. Then you say give input 1, give input 2, and then say predict button. Now, when you click it, this code has to be executed and you should get a page which gives you the result. So your client would launch this web application using a URL, and when he sees the web page, he's going to enter the details and he's going to get the result. Very simple. In the backend, this code has to be written, executed. So we are going to now learn on how to develop this web application using a very simple package or R library, which is known as Shiny. R Shiny. Now this Shiny application, or it's basically a library or a package, you can say, is developed by RStudio only. If you go to RStudio website, let me go there again. I'll say rstudio.com. You see under products here, you see Shiny server, R packages, Shiny, R Markdown, Tidyverse, and more. So Shiny is something which is very popular. I'm going to server, Shiny server. This is basically an application which is readily available for you to utilize online, basically. So you can also have cloud-based hosting where it's more like you can say a dashboard development application like Tableau. And you can also use Shiny server open source option. So just like RStudio, you have this. But how am I going to implement this in my code? That's what you need to understand now. So let's try and understand this. So I've given the introduction. Now you see this curve there. You see this visualization. This visualization, I'll show you this visualization also. This is an output where based on the input that you're going to choose here, the output should get altered. Okay, this is like X power input, whatever that you are giving input here. I can take values from 1 to 5. So if I put X power 1, if I take X, right, then you basically Y is equals to X power I. Okay, if I take I is equals to 1, then if my X is 1, Y will also be equal to 1. Right? That's what this equation says. So you get a straight line like this. If I take Y is equals, or if I take X square, then for every value of X, you get a positive value of Y. So here X is equals to 0, it is here. If your X is equals to 1, it will be 1 only. If you take X is equals to 2, it becomes 4. Y becomes 4. So on and so forth. You can see this this curve, U-shaped curve coming up. If you say X is equals to 3, then it gives you a S-shaped curve. So on and so forth. So how can you develop such an application which can change itself on the fly when you give an input? How much time do you think it will take to develop something like this using R? If you're familiar with Tableau, then you know it's a very simple task. But if it is in R programming, then you might imagine that it's going to take a lot of time, but not really. It's a very, very simple code that we will be doing. And that is done using Shiny library or Shiny package. It's an R package. It is used for creating interactive web applications or dashboards. Okay, just install Shiny package just like any other package that you do. Now the beauty of this is the entire user interface that you're seeing, the widgets, the graphics that you're seeing on the page is internally automatically rendered. You will focus only on your code. Of course, you'll have to map the input to that UI. That's something that we are going to learn here. But the beauty of R Shiny is you are going to write a simple R code. That's it. It internally has a web technology, right? It embeds the web technology and it gives you a web interface for your R code. You don't need any additional packages, not required. Very simple Shiny application. You will be able to install it in your local system, just like any other R code that you're going to run. You'll also run this. You can also use shinyapps.io. It is a hosted server like what we have seen on your RStudio website, right? You can also directly go there. You create an account. They give you a public cloud space where you are going to put your code and you'll get the interactive dashboards when you execute that. So that is another medium where you can use. Or you can also use your web browsers. You get a URL and you can use those web browsers for your integrating with your websites. So yeah, these are the features of your Shiny app. It's a simple web-based applications that you are going to face. And there is no JavaScript again. I'm saying you don't need to write any additional code or nothing. You don't need anything. Just R programming is good enough. And these are live by default. When you execute, the dashboards would be live. That means you'll be able to use them. Right? And as I said, it is dynamic. You can change the input and the visualizations will get affected in real time. You don't need to reload the browsers and all that. It is refreshed internally automatically. The code is getting pushed to the dashboards. It uses internally all these features only, but you don't have to deal with them. The Shiny library is going to give you an easy interface for you. And the beauty of this is the widgets. Widgets means the look and feel that we are seeing, the boxes, the slide bars, the tables, right? All those things that you are going to see are predefined for you. You're just calling them, right? And you can deploy it on local system, as I said, or on cloud, or on your HTML websites. Now, in prior versions of this particular library or package, it used to have a single, it used to have two different codes. It used to call it as, we used to call it as server.r and UI.r. Two different codes were developed. But now it has merged into a single code, app.r. This made the development furthermore easier. Of course, internally, you'll have two modules or two parts. One is the server r.r part, the other one is UI.r. But now you're going to develop everything in a single code, single R file. And this has three major components. The R, Shiny R application that we are developing will have three different components. UI component, this is user interface. Then the server function, this is your actual code. What is that you want to implement, right? That part. And then call to the Shiny app application. You're calling that function, right? So you're going to execute it, and it is going to execute this code with this UI. So user is going to have an interface here, but within that, it is executing this part. So these are the three different components that we have. And we'll try and understand what is these UI.r and what does server.r actually consist of. So UI.r, as I said, is a user interface. User interface or user UX, basically. And this basically is laying the foundation for your look and feel. Yep, object controls the layout and appearance, basically. Whatever you want to, basically, your user to experience. That UI is going to be written in this component, UI.r. And as I said, the widgets or controls are readily available. You're going to just select which one you want to put it there, put for your end user. The syntax would be like this. We say fluid page, open and close. That's it. This is the high level syntax. And we'll see the code also. Will be very easy sense for, very easy, and it will be fun in writing codes in Shiny. So UI is basically dealing with the user side of things, the look and feel, the interactivity part. But in the backend, what is the exact function or code that you want to actually execute? That is this server.r function. It contains the instructions basically that you want to develop. It's the code basically. We call it as the brain, right? And this is the syntax. But what we are trying to do in server.r is, using these keywords, we are trying to map or we are trying to pass the input and output that we are going to get in this code, right, to the user interface. So you have to pass the information to UI.R from server.R. So that communication is happening using variables. We call them as, of course, variables, right? So this variable mapping is what we have to take care of. And just like how you write your regular R codes, you're going to do that. You're going to import your data, then you're going to generate visualizations or execute some code, right? All those things are as usually done in server.R. Okay? And then we pass that data using these variables. These are the two types of variables. Input.variable means, as I said, in that example, right? You're going to pass input 1. You're going to give a field called input 2 to the users, right? So user is going to enter his input here on the web interface, the UI. So this needs to be passed, this is the UI, this needs to be passed to the code, the actual code. So that mapping is done using input variable. Now this code, when executes, gives you a result. Now that result again has to be passed back to the UI, because here you are going to show the result. So that output will be passed through input variable. So we are referring to the variables using these standard two input and output variables. So input variable represents the input widgets and controls or the user input. And we pass that to server. So server.R receives that input. And output would be the output or result that has to be rendered on the UI screen. And this is basically sent to the UI part from server.R. Very, very simple logic. Any confusion in this UI.R and server.R? Not input file. I never said input file, Sundar. I said input value. No, you're not writing any HTML or CSS code, nothing. What file? I didn't understand. You're going to ultimately load the data into R memory, right? How do you load an input file or how do you load data into R, Sundar, when you're writing a code? Regular R code, how do you do that? If it is a CSV file, what you do? The same thing you are going to do. I'm saying it is simple R code only, right? Same way you do it. Nothing changes. There are a number of different applications, Praveen. Yeah. All right. So this is from Shiny's perspective. UI.R, server.R, and the variables. Yep. So this is Safi. I'm going to show, of course. First, I have to explain what we are trying to do, right? Yeah, we are going to do that. Yeah, R Studio only. All right. So this is about the concept of Shiny application. And whenever I talk about code, to develop this application, you see the code is this much. And I've broken down this code to explain that there are two components, UI.R, server.R separately. UI.R is basically talking about the user interface, right? What you're seeing here, you're seeing a slide bar because this is the input that user is going to work with. So as a user, you're going to slide this. When you slide this front or back, that would be your input. So that is being defined here. Fluid page, you're saying slider input exponent. and you're giving a label saying choose an exponent, and that sliding bar will have minimum 1 value, maximum 5 value. And this value means when the rendering happens and when you see the page, for the first time when you see the page, by default, 2 would be selected. Okay, that's the input. So you're calling it as exponent and you have a label. So choose an exponent. This is the label, right? And the input is your exponent. Right? By default, it is 2. Then the output that you are seeing is called as curve plot. But this curve plot is actually mapped here. Right? And the exponent that you are seeing, the user is going to give this input, right? That you are passing here. So user when passes or gives the input by sliding that value, slide bar value, input is recorded here and it is passed to this function, server function as input, and this input is here. And this is going to give a plot. You're saying render plot, right? A visualization comes up, curve. This becomes your curve plot and you're mapping this to output, right? And this curve plot is defined here. That's it. Very simple. So this is your actual code. This part is going to give you the output and you're saying render this. Render plot would give you that output. Very simple R code. Right. So here we are seeing this application. Guys, ask some logical questions, guys. Why -5 means what is that question? It's my choice. I'm giving something like that. This is a curve that I'm developing. You can give -10, your choice. That's a range that I'm trying to project here. But the number of inputs are fixed. This code works on that, Yasha. This is an example. Yeah. So this is basically one of the example which gives us the slider bar. Okay. And for executing us this code, whenever you're writing a Shiny application, you will see when you give the function, right? When you import the Shiny application library and when you give that calling function, you will see this button. Ideally, in RStudio, you see only run button, right? But when you have Shiny application developed, you will see run app button coming up there. And when you click it, it is going to give you the output in a user interface. You can also choose that into a web browser also. So that is very simple R code. Let's do that. I have few codes. Let me show you this exponential curve. Yeah. So this is how your code looks like. UI, I'm saying slider input. This is the input that I'm defining. Label on the visualization will have this name, choose an exponent, minimum, maximum, and 2. And my output is being printed here, the server part. Pass input, output, and call the session. Output would be this. And you're ranging your curve from -5 to +5. And you're going to execute this. And as this is your calling function, Shiny app. UI part, you're defining it as UI only. Server part, you're defining as server only. You can give any different names also. That's your choice. But standard, we use the same names. Ideal practice, general practice is this. Now you can see here, run app is given. Run app is given. run in window, run in viewer pane, run external, right? All these things are given. Different options are given. If I remove this calling function and save it, you can see it is now becoming your regular run button, regular code. You see run option, right? So it automatically does that. So let me save this and execute it. So you see this output? By default, I have passed here that I want to take by default the value as 2. So you get, if I take x equal to 1, see the curve changes by default. I say x equal to 2. This is what you're getting. X equal to 3, x equal to 4, and x equals to maximum 5 that we're taking. So live, as and I've changed this, the visualization is changing. You can also move this to browser. Click on that button, open in a browser, you get this output in a browser like this. Here also you can do the same thing, slide it here and there, and you get this output. Right. So this is about your Shiny application code. This is one example. You have a lot of these examples given in your LMS as well. For every machine learning predictive algorithm, you have R code, Shiny code, and Python Flask code. I'm not sure if you have explored that or not, but you can use those codes for experimenting. Right. Now, what all other visualizations we have? This is a simple example. This is something that you can also take. This is given by, let me stop it here. This visualization or this code that you are seeing is directly given by your RStudio only. Right? It's given by RStudio itself. Okay, I see so many messages. Let me take the messages. Yes, Manoj Reddy, that's what I was saying, right? Yeah, you'll have to write this UI part and server part in the same application. In the prior versions, it was 2 different codes, but now you don't need 2 different codes. It is same code. Next question. RStudio website has our, yeah. There are a lot of examples. That's what I was actually opening now. These are the examples. You can experiment, guys. Remember, this is a pre-written code, pre-written widgets. You are just taking those things. Those are the standard, I should say, syntax, Rupali. Standard syntax. You can say yes, Ankit. You can call that, yeah, again. I've changed the input, right? You have seen that, Shweta? I've changed it. On what basis do we choose? That depends on multiple aspects, Ravi. You cannot give a standard answer to that. Of course, if you're developing any AI application, then obviously you'll have to go with Python. We share only the link or our code part. This is code, right? You're going to give the code, obviously. When they execute it, it is going to be in URL. So you can execute a cron job when you're developing this, or when you're implementing in the customers or clients' servers. Based on the requirements, you are going to execute this and make sure that the live application is available. So when I execute this, right, I'll dedicate one session here, and this particular page is readily available. You're going to say open in browser. This web browser is there. I'm going to redirect this to the web page, to their websites. On the websites, this is anyways, application is always running. In the backend, your code is always executing. Tausif, yeah, obviously you are developing R code only, right? There is nothing new. It's just the two different steps are there. Two additional steps are coming up now. And the widgets you have to learn, and just like R code, these widgets are readily available. Okay, when I close that web application, the R code, right, release the execution. But when you're executing, when the web page is live, the session is live, you can give input and you get the output. Right. Ankit, I'm not sure if you are familiar with R. If you are not familiar with R yet, then you can hold on, discuss about all these things. Then you'll make sense how to install everything in R and how do you actually start working with R. And people who are familiar with R programming, they already know. It's very simple steps. You see, this is the example. You install the packages like this. So I'm importing this library. And then I'll say run example. 01 hello. This is the visualization. These are all pre-written codes for you guys. Okay, and as and how I change the slider, histogram, the bin sizes is changing. Okay, yeah. Right, so this is about your histogram. Okay. Oh God, okay. I see so many questions. Okay, let me see the questions again. How do we arrive at the web application like the one where we have to fill the inputs after getting the slider on the URL? Okay, Yasha, there are different examples. You have to hold on to the examples. Wait for some time. I'm showing these examples. Can we use a SSL certificate and deploy it instead of... Yeah, you have to redirect that, right? So you are going to define the server where, or the host name where you want to deploy this. This is a local URL, my local system. I'm running it in the local, right? If you have a server, then server will have a specific host name. That host name would be coming up here. You're going to use that host name and use it. If that server has SSL implemented, then obviously it will be SSL enabled. Okay, client wants to run the program with live files daily on to see results, as they will not make changes to the program to give the file path. They need user interface only. Select the today's input file. Then you have to pass that location somewhere. That is not our job, Sai. You do not take care of SSL certificates and all that. That's a different team altogether, right? There will be network team, security team. They will take care of the SSL certificates and all that. They give you a server to deploy. Remember, we are data scientists. We are not developers. So we cannot do everything. With the help of the developers, we will be able to implement this kind of a visualization. Right. So this is the first example. Hello, Shiny. This is talking about histogram. And I can change the bin sizes here. Now, you might say that, hey, where is the code? Scroll down, you will see the code here. Now, these examples are readily available in your RStudio website itself. Okay, you can play around with these codes. Detailed explanation is given about these code also. We are implementing Shiny. You're calling the library. Then UI.R component, that UI component, your title is Hello Shiny. You're saying sidebar layout. Your sidebar layout. You're calling it as bins. Input data is bins. You're passing the bins here, right? This is the input ID. Number of bins, 1, 50, and 30. By default, it would have give you this image, number of bins, right? So title of this particular page is Hello Shiny, and this would be your input slider input. and output would be your plot. And you're saying output plot. So what you're doing, your server basically is using these variables. Input is pulled from UI part. And when you get that input, you're going to define this bins plus 1, that is your output length, and you're going to come up with a histogram with these bins. You're defining that bins here based on the input that you get from the user input. And then you'll get a simple output, right? And this output you're passing back to your this distribution plot, and that is given here in the output. Output plot is this, and you will see that on the screen. Automatically, everything is automatically taken care of. You just write what is your logic, use the standard syntax, and boom, you get your visualizations. This is one example. I have text file. I execute this. Oops, sorry. Yeah. So second code, this is text. So here you are choose the data set. There are two different, multiple data sets. These are inbuilt data sets, and you are looking into your data set. That's it. This doesn't do anything much. Based on the input that you are passing, it visualizes your data set. Data set, choose a data set. You are going to choose from one of these three, right? And you're saying select input. That gives you that drop-down list. And you get summary and you get view. Summary and view. This is summary and this is view. These are the two outputs. Number of observations to view, that is also an input that you can pass here. So you have two inputs basically. And using those two inputs, you get output here. So this is about tables and data sets. This is another visualization. Yeah, this is your same visualization. We're calling it as caption. You can see this is the code. Just extending the same code a little. You're passing three different right, inputs. This is the caption, data summary. You can change the caption also. And you get the data set, view, and summary. Global variables. This is another visualization. So you have all these right, different visualizations. These are all the widgets that are readily available for you. Here you're talking about box plots. If I remove this checkbox, outliers are gone. If I click that, outliers are shown. This is for the cylinders variable. Then I have transmission variable. Then I have a gears variable. Right? So here we are using data sets, inbuilt data sets. I'm calling empty cards and giving labels, converting the data into factor type. And I have choice to make on what is the field. And then whether you want to see the output outliers or not. Checkbox input. Select input means drop down. Checkbox input means that you give that box is given here. You selected this box, right? This is the input, checkbox. And then you have the output, which basically is box plot. Right? So simple. Your R code only, just enhancing that for a better view. Okay, again, I see a lot of questions. Okay, how many of you are actually practicing R, guys? I see a lot of questions coming in. But before you ask all these questions, I want you people to try this out. Okay, don't ask. Start doing. Rakesh, it's already there in your LMS, Rakesh, as I said. These codes are already there. Nothing, Ujjwala, you just have to implement these 2 lines. That's it. These are just like any other packages. Customization is what you can do, Ganesh, but there are restrictions because there are predefined widgets and your customization has to be surrounded only in those visualizations. For example, rather than sliding bar, you can use a drop-down list to give the input. So those kind of customizations can be done, but you cannot change the UI completely. Yes, I'm covering that Flask also, but let me first finish this. As I said, it is not mobile friendly. The web application that we are talking about on HTML pages, not on your mobiles. It's not mobile friendly. Suppose in multi-layer perceptron, if you want to give different optimization functions as an input, can we visualize the output on algorithm? Visualize the network you're talking about, Ankit. You might want to try out. See, if you are able to visualize it on regular R code, like your normal R code, then you'll be able to do it in Shiny also. But Shiny would be more dynamic. If you want to change a parameter, then you change it and execute it, your output will change. Automatically the execution happens. Ankit, it will take time, okay? Not to worry. These things, R code, once you are familiar with R, then it's very easy. So for you people, you have to wait. People who don't know R, you have to wait first to learn R, then you'll learn about R Shiny. It's there, Tausif. As I said, it is already there. It is very simple. You have to use run example. And these things are also there on your RStudio website. And majority of the codes are already there in your LMS. Okay. So let me also execute a simple R code here for prediction. Again, this is also a code that I've downloaded from your LMS only. Prediction models, Prashant, did we go there? Are we doing predictions? If you are in that batch, if it is covered, then fine. In any of your supervised learning techniques, you will see these codes. If it is not covered, then probably you might not have seen it, but all those things are already there. So simple linear regression, if you talk about this, this is in LMS only. You can see Python Flask, then you have Python Flask code, Shiny simple linear regression code. For Python code, I also have a different data set. All these things are there. Okay. For every code, Naive, you can see Python Flask code, R Shiny code. It's there. Okay. All right. So this is about the Shiny, and let me show you this. So here, people who are familiar with multiple linear regression, for you people, remember the 4 inputs: horsepower, volume, top speed, weight. And these are your inputs. And you're basically giving a numeric input. Numeric input means you will have a text field, a box in which you are going to pass the data. And you get output. You're basically calling it as disk plot. So this is my code, right? I will have to load the data set. Then I would use LM function, develop the model. And then using this model, I'm predicting. I'm predicting here. I'm defining this inputs that we are capturing from here as a new record, new data. And then using this new data, I am trying to predict using this model that I have trained here, predict. And when I do the prediction, you get output. And that output is being passed into your disk plotter. So you get output printed in a table output. Again, you'll see a table kind of an output, a checkbox kind of a thing. So this is what you are going to learn as part of your regular class, right? Linear regression class. This is the code that you are going to learn. So I'm just putting a wrapper on top of that. And that wrapper is this UI. So if I execute this, this is the input, cannot open the connection. That could be because I don't have the file located in this particular folder. I don't have this, is it? Let me edit. What is missing? Okay. This is the folder name. Let me execute it again. Yeah, you can see the output. By default, it is 1. So you give some data as and how you are going to change this. Yeah. Your output is getting predicted here. So dynamically, as and how I pass the input, the output is changing. So I want to predict mileage. So I'm going to give the horsepower of the vehicle, the cubic centimeters of the vehicle, top speed that that vehicle can go, what is the weight of the vehicle, and I get the mileage here, right? So based on your input data, based on this data set, you have to identify what are the values. You can also have restrictions on the input. You can say input could be between only this range to this range. All those additional code can be written here. And then based on that input, you're going to do the prediction here. So this is, specifically for people who understand what does linear regression means. This is how you are going to develop your web application. No problem, Jason. As I said, this is only to give you an understanding for you people who don't understand R. You can imagine that there is something very simple technique which can basically give you a web applications developed. You don't have to become a web developer to do these things. That's what I want to project for you people. Yeah, Harish, as I said, just again explaining, it's just to give you an overview. Again, Saurav, which batch you are from? Are you not familiar with R programming? If you're not familiar with R programming, you'll not understand that. Predict is an inbuilt function. It's an inbuilt function. Okay. All right, so this is about R Shiny. Now let's move on to understand Python Flask as well. See guys, people who just started with R, or for that matter Python, it will take some time for you to understand the code because you don't know R code at all, right? It will take some time, not to worry. Any type, Raviteja, when you want to give web application, we use that. Any prediction screen. It depends on what your client is actually requiring. What does he want? If he says that, hey, I want a web application developed for the solution that you are giving. So for example, the mileage example I'll give you. Your client is basically running a, let's say, service station. four-wheeler service station. He wants to basically sell vehicles, right? Second purchases. So you are going to help him develop this application, which is going to predict the mileage of a vehicle based on the input features. Based on the mileage, he's going to take a call on the price. So in such cases, when a client is sitting in front of him, they want to sell their vehicle. So this guy purchases and sells it back to different customers. So he's going to ask the customer on, hey, what is the vehicle? What kind of vehicle you are driving? And all those things are given as input in that application. And he'll just see the result. Based on the mileage, he's going to comment on the price. So it depends what kind of application or what kind of use does client have on our solution that we are developing. Yeah, there are different applications, Ravi Teja. But see, does client require these kind of heavy UI applications? Is that the requirement? Maybe not. He cannot hire developers and all that. In that case, these kind of applications would be good enough, right? Yeah. Ravi, this is starting afresh only, Ravi. This is a webinar. I'm not sure why you're not understanding. I'm saying this is a webinar. This is for everyone. So people who have already completed the program also joined. People who are just joined us, they are also learning this. No, Sampath, you have to give the data in specific format only, right? Your training does in some other mode. If your model learns in kgs, obviously you have to give that in the kgs forms only, right? That is something you have to deal with in your code itself. You cannot change the input. Web application is executing just what you are writing there. Okay. All right. So this is Python Flask. We are going to start with Python Flask now. Okay. So when we are dealing with R programming, if you are dealing with R programming, then you have R Shiny. Okay, we have learned about that. But if you are dealing with Python, remember Python is a generalized programming language. It's used for generic purpose. Okay, so there are a lot of web application options that we can use for developing these rendered images or dashboards in Python. Now we are going to talk about this specific tool or application you can call, or language you can call it as. This particular Flask is a web framework, and it is called as a lightweight web framework. Very, very simple and very small, or it also has got name as micro framework. It's known as micro framework. Very light. There are other web frameworks which are there, like Django, which is a heavyweight framework. But this is similar to what we have learned just now in R. But yeah, Python generalized thing is there. So there are certain things that you also have to try and understand. HTML and CSS. Having basic idea about these things would help. Otherwise, again, just like Shiny app, you are going to take publicly available code, make the modifications, and then use it. And understanding this HTML tags and CSS code is very easy. So you're going to take existing code. So what exactly Python Flask is all about? As I said, it is a lightweight web application, just like what we have seen in R. Again, to print something like this will take very small amount of code. Right. So So Flask is a lightweight web server gateway interface. It's nothing but web application framework. Right? What is the time? 9:45. Okay. Yeah. Better we take a break. I did not see the time. I was just going in a flow. Yeah. We'll take a quick 5 minutes break, friends. It's 9:42. Let's connect at 9:47. Okay, 5 minutes break. Let me start fresh with Python Flask post the break. Praveen, there are n number of different applications. Right? Majority of them are very simple ones. But these are the things which are used. I mean, these are something which are generally practiced. These are new things which are coming up. Initially, it was Java. Later on, now Python is there. In future, there might be some other programming language which might evolve. So new applications will come up. A number of different things are there. Yeah. See, ML, as I again repeat, let me repeat this. ML, machine learning, or you can basically say data science, is still evolving. Even today, it is still evolving. It's a research-based concept. So because of not having any standards or standard methodology, or I should say fixed rules, there's a scope of bringing in new things in data science community or this space. So there's a lot of new technological enhancements, new tools that are coming up, right? Yeah. Constant learning, yes, that's very, very, very much required. So a few years back, nobody knew what is machine learning. A decade ago, very few selected people would understand what does machine learning AI means. Those days, AI was just an imaginary concept. Machine learning slowly started based on statistical methodologies. Then we started to implement them into business scenarios. Business data science became very, very popular. Then machine learning, you have black box techniques. From there, AI slowly is evolving. AI is still evolving now, even today as we speak. Right? Now we are talking about explainable AI. But all these things are from a standalone point of view. In implementing this, the deployment, we have MLOps. Big thing, guys, MLOps is next big thing. If you look into the job descriptions today, open any LinkedIn or whatever that is. If you look at job descriptions, people are talking about having any one of the cloud experience, hands-on in any of the cloud. And how do you deploy your applications on cloud? Right? So that is something people are talking about. And that is what is called as, I can say, auto ML. And then this auto ML in cloud, we are basically talking about MLOps. Next big thing, guys. Majority of the jobs are here now. Slowly. You're a data scientist, very good. But can you deploy an application? If you can deploy it in cloud? And can you generate a pipeline so that my solution or whatever the solution that we are working on can be used on scale in production environment? Can you do that? These are the questions that you have to try and focus on. Okay. Now, Python Flask, let's come back to this. Python Flask is a web application or framework which is lightweight. Right? We call WSGI as web server gateway integration. Interface. Now, It's very simple, easy, and as I said, it is a micro web framework. Micro web framework basically means it's going to give a very, very small application for you, but it can be extended. Okay, by default, it is very small application, very lightweight application that you're going to, I should say, deploy on your server. In the backend, there will be a web server that would initiate. And the flexibility, right, and the scalability of this particular web framework is immense. And you can connect with any of the databases. You can configure any application, irrespective of the application and the database. You will be able to develop your web applications, right? So there is no restriction on the choice of databases and the web the applications that you are going to use. It is a simple wrapper on top of your Python code, right? And it is developed on Jinja. Different people have different pronunciations. I pronounce it as Jinja. And this basically is a template engine. Web template. It is called a web template engine. Now, this web template engine, right? Basically, it has a lot of templates, pre-templates that you can use for rendering your dynamic web page. So Flask picks up those templates basically. And as I said, you can also hear something as this is also another web interface or web framework which is very popular in Python, but this is a very, very heavy application. So for medium scale and small scale applications, Flask is preferred. We take Flask. Oh, voice is breaking. Okay. Could be a network issue, guys. Not sure. Yeah, now it's clear, right? Yeah. Okay, so I was talking about the lightweight web framework. WSGI is nothing but web server gateway interface, which is a web server basically is getting initiated when you are developing Python code and trying to render your web pages. On the client side, this small scale, very micro scale web framework will get installed and web framework would be initiated. And this would basically use Jinja templates. Again, if you are a developer, you will basically try to understand all these terminologies. Don't worry if you feel that these are new words, new terminologies and all that, that's okay. You just started. Okay, slowly you'll be able to understand this. And as I said, having an understanding on HTML and CSS or HTML is very much required. And having the understanding of these codes would be beneficial. It's not mandatory again, it is beneficial. So these are features. It's a very small, easy to understand and easy to use application. And they work over HTTP protocols. That is over web. So this very simple web-based, this web server application gets installed. And as I said, this Flask is a very good choice for small scale applications. If you have a very big project and one of that small application or one of the module has to be, you have to have a web application for that, then you can probably use this Flask as one of the module there. Yeah, as I said, it is preferable for small applications. These are the features or USPs of your Python Flask. RESTful request dispatching happens. It has a very good extensions, a lot of right? Extensions are readily available. Web server compliance, and it's an open source. So there is a very good community support. You have any issues, you can approach that community, and they basically have readily available solutions. It's a very widely applied application, right? So a lot of errors are already solved, bugs are already solved. So good community is there. And to understand, right, you can always go to the Flask open source website, and there's a very clear and precise, huge documentation available. Okay, and a lot of APIs are also readily available. Majority of the open sources, if it is popular, then a lot of things are readily available. That's one of the good thing with Flask also. And because it is very lightweight, a lot of people prefer it. For installation, you're going to say pip install Flask. This is the process, or this is the step on how you install Python packages, right? So this is also a Python package. Just like how we have seen our package, here you have Python package called Flask. And if you have to work with databases, then you will say an extension, pip install Flask SQL Alchemy. So very simple. These are the installation steps. Now looking at, once you have installed this, if you have to look at and understand the code part, this is the syntax. It will be a little, right, to have a first glance at it. It looks like it is too much of coding, too much of these, what do you call, developer kind of impression, right? R is like English language, but here you see these things, they're coming up. It's like a pure code, right? But again, it's standard steps are there. You have to copy paste. Majority of things are readily available. You just have to take the readily available code and make the modifications. But as I said, you need to understand the HTML syntaxes and all that. So from Flask, I have installed Flask, right? Pip install Flask. From Flask, I'm importing the Flask function. This is the library or package with small f and capital F, uppercase F is there for your function. And you're calling this Flask application. You're defining a Flask application there. You're giving a name. This is the global generic name, standard name that you give. Double underscore is the syntax. You're saying this is the name, and you're saying this is a Flask application, and that application, you're calling it as app. This is to initialize your Flask application. Okay, and then we basically have @app.root. So you're basically routing your web page, your application to go to the home page. / is basically your home. And within this home page, on your URL I'm talking about, you have this hello world printed. That web page will print this hello world statement. So generally your web pages have, if you see URL, it has all these things and then /, right? This is your URL and /. So /, this is your home page. You'll have in the home page this printed. And if you are deploying it in your local system, then your local host will be taken here. This is your local host, just like what you have seen in R. So it is picking up the host name, the local host name, and then it is creating a web application, web pages. And in home, you will see hello world. Right? So the current module is this. Right? We are basically giving the current module. And then root function, right? This defines the URL mapping basically. It has to map, right? Now, if you have another web pages, multiple web pages are there, then you will have those web pages like slash and let's say home, slash and contact us. Like this you'll have, right? Different pages. So on those different pages, you will have subcode written like this. So this root is basically mapping to your, or routing out to your associated functions to your UI. So that's about your basic Flask application. And this is how you're initializing your code. That's how it is basically calling. And you have to basically set this when you're running the application. When you're executing your Python Flask code, debug should be on. App.run will initialize in debug mode. If this condition maps, then it will initialize your web page. So that's how your Flask code is, and this is the definition. So you are basically importing here your module or function. Then name is the current file or module, which is your web application basically, and you're calling it with a name called app. So it will initialize a Flask class. Yeah, this is nothing but your WSGI. Web server gateway interface, or web application in short. Line 5, this is your default page, main page. And 6 and 7, these lines basically are representing what you will see on that web page. Right? And here, 9. This Python script would be executed when you are initializing this Python script. The Python class it's basically assigning this main class, main script or main class. If your name, when you're executing this Python Flask, if your main function is executing, by default it is a package, it's like a class, right? So when this main package is executing or main script is executing, it is verifying whether this, okay, it is written here. When we run this application, so this name is converting into main function. And this is a standard for your Python packages. And when it gets transformed, if this is getting changed, right, if both are mapping, then we initialize your web application. That's what this line means. It's a standard process or standard methodology that we have to use. Right? And when there is any errors, then those errors will be picked up in this debugging messages. And to get those messages, you need to say debug is equals to true. In the backend, you will see that messages. Right. So that's basically the syntax of your Python code. Right. And this is the explanation of your code. It's like your, if you are from programming background, probably it makes sense for you to understand that when you're executing code, there will be main class, subclasses, and all that, right? So that concept is used here. Okay, this is by default your main class, and this application when you're writing, if this becomes your main class when you're executing, then you're basically internally this code is renaming as main function, and we are verifying did it change or not. If it is changing, then your web application is started. Right? That's a simple way to put it. And yeah, that's it. Basically, that's what you have. And these are the references. You can go to this web pages, and yeah, you can basically read the documentation a little detail. And yeah, this POCO that you are seeing here, POCOO, this is basically an open source Python enthusiasts group, Python community basically. It's an international group of Python users. Anyone can enroll into it. And yeah, I don't remember the person name who started this community. He basically developed Flask. I forgot his name. You can visit this particular website and you can basically get the details. And you also have these web frameworks. Under this web frameworks also, you have a lot of other additional web frameworks available. Yeah, Tosif, thank you. Armin, exactly. So Armin his name is Armin, some Rocher or something. This guy has developed a Flask application. Right. Yeah. Yesha, I want you to try the code, okay? It's not a slider bar. You look into the code, you execute the code, you'll understand. It's not slider bar. Yeah. They become famous, Sampath. They don't get money. Open source means you're giving away for free. So you'll not get money, obviously, but you'll become wicked famous. And based on your open source or whatever that you're developing, if that application becomes famous, a lot of people will come to you, right? You'll become a freelancing consultant then. Right. So let me run through the Flask code also. Here I have Flask code. Let me go there. Yeah. So I'm going to go to this main code. This is simple code that you have seen. But if I have to execute this, I need to have my Python code or Python script started. Okay, this is my Python interface. You can start executing the code by saying Python space the application, the code name. Right? You can simply do that. But let me first navigate to the location. Let me come there. So let me go to that particular location where my file is there. So this is in the directory datasets. Then we have webinars. CD webinars. Then I have CD Python Flask, and you have these folders. This is my code. So all I do is execute this here with Python, or you can say py, or you can say Python. Both will work. If you don't want to give full name, you can say Python and say main.py. And you can see the application is initializing. Copy paste, but when you're copying, make sure do not press Ctrl C. For copying, if you say Ctrl C, it would quit, it would cancel this particular application. So right click, select it, right click on the mouse, and you'll get that copied. And I'll come here onto the web page and select this, and you can see hello world is printed there. right? Okay, I see this. Better to go with Spider, Jupyter Notebook. Yeah, you can use anything. Yeah. Absolutely. You can use Jupyter, Spider, anything. And you can just say, execute this py.code, or you can execute the complete code here. You press this button, green button, right? So that way also you can do it to get the code executed, right? Gautam, you can visit the LMS. You can get the links. Why you want me to copy that? You can go there and type it. I cannot copy paste it. It's not there. Copying is not there. The resources are readily available, guys. Why don't you explore? There are so many resources available. Right. So this is Hello World application. I also have different application here. This is to show you a different code. Let me show you this code. Right. So this is your code, Python Flask code. I'm loading Python Flask, and along with that, I'm also loading additional libraries, render template, URL for request, right? All these are extensions for Python Flask application. Then you are importing pandas, pickle, sklearn modules. I'm developing KNN model here. So from sklearn neighbors, K-neighbors classifier I'm importing. It's a prediction or classification model. And here I'm calling the name. I'm basically giving a name as app only. This is the default home page, right? This is the main page. And here I'm defining home. I'm calling this template as home template. And then I also have /predict. So there are two pages, / and /predict. So in this prediction page, you'll actually predict the output. So it is reading the data for training purpose, and it is developing a KNN model, and you're fitting the output. You'll get the output, right? And this is the extension that you have. SL, SW, PL, PW. These are the 4 inputs that we have in this data set. Sepal length, sepal width, petal length, petal width. That's your data frame. This is for new input for prediction. Here you are training, and when your new input comes in, you want to predict the output. So you are saying results.html. So it's going to redirect to your results.html page, and that page will be there under here, results.html and home.html. Look at this. Home.html will basically have this, and the output would be there in results.html. These are both HTML pages, right? So this is results.html and this is home.html. This is how your HTML pages would look like. And remember I said, this is the code, HTML code. So you have to basically understand this HTML coding as well. This is the difficult part in Python Flask. Okay, it's not as easy as Shiny R, that I have to admit. R Shiny is super easy. You don't have to worry about anything. But here you have to basically start learning on these things also. But as I said, these things are already there available. You're going to take that existing things and change, alter your names, look and feel, and those things. These are user-defined, Upendra. Yeah, we need to have this basically directory. Yeah. Template, you don't have the template, right? That's the reason it is throwing error. You need to have this standard syntax also. So along with your main application, app.py, you need to have this folder called templates. By default, that application is going to look into that folder for these pages. What pages? home.html and results.html. So you are going to develop the HTML backend, and those HTML backends, the parameters are defined here. Right, so in home.html, this is your thing. So you're calling it as ML regression, machine learning model. You're calling the brand as ML and prediction, and it has 4 inputs. And you need to click on submit to get to the predict page. Input is submit. When you click on submit, the value, it redirects you to predict page. Right? So this is what you get. And once you do that, this is basically your home, right? So you see this predict button is there. You click on that and you'll get output. And that output redirects you to results page. And this one is the results page. As I said, HTML and CSS again. Container app, this is your results. And this is the class results, and you'll get output predictions. And you have to basically see your code to understand those names, mappings. Prediction, you're getting prediction. Okay, that's your output. Output name is prediction, and this is the value. Species is prediction. Salary is so much. Basically, whatever the data that you're using. Right? So that's basically it here. MyPred. How do you get MyPred? You're predicting this. What is this prediction model? This is your KNN model that you have trained here. You take the input as a data frame, give the names, and then do the prediction. Simple. Right. So here we are basically seeing this output. You should say species. I have to edit this. Okay, let me open this in HTML. This is not salary. This is species. Yeah. So save this. Okay, and if I refresh this, it's changing. Yeah. Okay. So now let us execute this particular code here. So I will cancel this. Control C will cancel the application. We'll close this. Yeah. I'll come out of this directory. I have the folder called KNN. I go into this folder and dir. I see that app.py. So I'll say py.app.py. And yeah, there you go. Let me open this. And we will open here. So this is my output. And you will give any data. Oops. I don't remember what are the values there, the range of the values. But yeah, we can give any random data values here. Let me see otherwise. Yeah, this is the data set. You have 4 inputs: sepal length, sepal width, petal length, and petal width. And these are the species. There are 3 different categories that you will get: Setosa, Virginica, and Versicolor. These are the 3 species of flowers. Scientific names are there. And we have to give these sepal and sepal width, right? So these values. So let me give it here. Let's say 5.12 or 13. Petal width, I'm going to say 3.6. Petal length is in the range of 1 point something. It's 1.9. And petal width is very small. So I'll say 4. Let's see. Click on predict. And it says it's a setosome. It's predicting. So this is how it redirects. So from here, if you see, this is the URL, right? You're getting /. When I click on predict, it takes me to the predict page where I get to see the output. So /predict, it's routing to /predict. This is your predict function. This is the entire predict function that you see, right? So when you click on that predict button, it is going to initialize this results.html page. Right, so that's basically your HTML code. Yeah, this is backend. Yeah, Python Flask is a little heavy from your backend side of things. Yeah. HTML, guys, basically it is all about HTML. If you understand HTML part of things, then Python Flask is automatically rendering everything for you. I should throw error, right? Samrat, try out now. So if I do that, NA, remember NA? This is what you're going to get. Can you solve a mathematical value equation without having a value? No, right? Sai, when you say data pre-processing, what do you actually want to do? See, if it is something that has to be executed when you are taking the final solution, then yes. Generally what we do, when we take the raw data, we take this raw data, then we do pre-processing, right? And we know, right, what all steps we have done here to get this data into a specific format. And you're going to try different models, ML1, ML2, ML3, so on and so forth. And among all of this, you're going to pick one model as the best model, ML final. All this is something you are going to do manually. You're not going to write all these into your Python Flask. No, your client would want solution. So this model has to be used in Flask or Shiny. You're not going to do everything. But to implement this, if your data, raw data that you are passing has to undergo some transformations or some pre-processing, then you have to write that code also. And then you are going to develop ML final. And then you are going to get the output. So that this part would be there in your Flask or Shiny. So ultimately, what is that your end final solution will be there in the Flask application or your web application, whether it is Shiny or Flask. Saurabh, see, if it is a mathematical equation, it gives you the output, but does that output actually make sense? Will that be accepted? You also have to look into that, Saurabh. Right? See, always remember when you are developing your models, if you remember, we spoke about this in regression, we generally speak about this. So if your input data has a specific range, let's say from 0 to 10 units, okay, horsepower, let's say this is your horsepower. For a given car or given vehicle, any given vehicle that we have seen till now, this is the range of data that we have, or this is the range of horsepower that we have seen. Now, we are using this particular data to train, right? And you are going to predict mileage on this particular trained vehicles. Now, if you're saying, I want to test this model onto a vehicle which has a horsepower of 25, do you think this model will work there? Maybe, maybe not. We have not trained the model, or we have not evaluated the model for such a value. So you will not have confidence to say that the model that you have developed here may work here. No, you cannot have the confidence. But this ML model that you have developed, you can clearly say that it is going to work with a certain accuracy that you're going to get if your input data that you're passing is lying in the range of 0 to 10. Only then you'll have a confidence, because you have evidence, you have trained. It's like this. You are preparing for an exam. You prepared from chapters 1 to 10. So if I ask questions in this, probably you'll be able to answer. But if I ask you a question from chapter 20, would you be able to do that? Maybe, maybe not. It might be a fluke. I don't know. When I'm evaluating, you might give a perfect answer, but I don't have a confidence because it might be at a fluke. You have trained only on these 10 chapters, right? So confidence would not be there when you are trying to do that. That is something you are going to develop, Prashant. Again, my same question, Prashant. Did we cover, or did you attend sessions for supervised learning? Did you learn? Did we attempt them? If not, then these questions that you're asking are not relevant. You need to understand those things first. Ideally, if a value isn't filled, shouldn't go to the results page. Yeah, obviously, NA, right? How do you calculate? Again, I'm saying if I have NA space, this is my equation, guys. AX1 plus AX2 plus, BX2 plus C. I'm leaving X1 empty. I'm saying X2 is 5. Calculate this with NA space. Don't you remember missing values imputation? Why you ask the same question again and again? You need to understand. If I have a missing value, I cannot do mathematical calculation. That's where we have learned about imputation. Yeah. Suresh, come on. You know the answer. We're asking the same question again. You know what to do. Yeah, this will be in your LMS. Yes, Abhishek. The session will be there in your LMS. Yeah. What you do, Suresh, if I have categorical data? Or anyone, what we need to do if I have categorical data? For prediction, we have to convert that into numeric form. One hot encoding or label encoding is what we do. Yeah. All right. Okay, I also wanted to talk about Git and GitHub, but I think time is not sufficient. We'll have another session for GitHub also as well. Yeah, Jyotsna, that is also one of the options that we can do. Yeah. All right. So this is about how we deploy a model on web application or generative web application using very simple, easy to use libraries. For R, we have Shiny. For Python, there are multiple options. We are looking at a very lightweight web application, which is called as Flask. Here you have inbuilt widgets that you can directly use. Whereas here, having HTML knowledge would help because you have to write the HTML web pages, and rendering automatically happens by these web applications or libraries. Right? So when you are practicing on the prediction models, try and explore these options. The codes are already provided to you. Not required, Partha. We never talked about any JavaScript till now. Not required. If you are familiar with this JavaScript, then yes, you can use that also. In Python, there are a lot of applications. Even Flask, you see, it is uses CSS, JavaScript, all those things. Right? Bouquet application, there's something called as Bouquet. There's something called as, what is that? Nine something. Yeah. So all these are applications which are available in Python. Sweetways, yeah, so many are there. No, Shubham, we are not developers, right? So we don't go into HTML and CSS part. That's not our job. Parth, as I said, there are n number of different applications. If you are familiar with these applications, then absolutely you can try and do that. There's no restriction on what you can try or what should not be tried. But from the data science perspective, if you ask me, I don't even know what is Streamlit. I've never explored it. Right? So I go with Flask because it is easy for me to implement. It's an open source. I have very simple Python code and of course, little bit of HTML. But if you say Streamlit is easy, probably I should explore that. So like that, it's just, there's no restriction. You can try anything. Yeah. Yeah, probably. I mean, I never had to, and so never explored. But yeah, anything can be tried. All right. So that's something that we discussed. Deployment is what we have tried to understand today. And I would want everyone again to explore what does MLOps is all about, how these machine learning algorithms are being deployed into the cloud. And yeah, we do have a 2-day workshop also being conducted. Do register to that. Right. All right, guys. We'll conclude for the day. Right, and we'll connect again with some other sessions, similar sessions, which are very, very useful for you all. All right. So until then, good night, guys. Thank you.